Hey guys, happy Tuesday. Before we go ahead and check our notes, we're going to watch two videos that I think will really clarify some things and help you better understand the material. So let's go ahead and watch.
Atoms and elements. Objective: to learn the fundamentals of atoms and elements. All substances that we see are made up of minute particles we know as atoms. These tiny specks are the fundamental units of matter. A substance containing only one type of atom is an element. For example, iron is an element because it contains only iron atoms. Similarly, carbon is an element because it is made up of nothing but carbon atoms. If we look inside an atom, we would see three types of tinier particles: protons, electrons, and neutrons. In the atom's center is the nucleus, which is made up of protons and neutrons. Protons carry a positive charge. Neutrons do not carry any charge, so they are electrically neutral. Electrons carry a negative charge and revolve around the nucleus in orbits. Every element on Earth has a defined number of electrons, protons, and neutrons, and these numbers are unique to that particular element. Every element also has two specific numbers that are associated with it: an atomic number and a mass number. Let's see what those terms mean. An element's atomic number identifies the number of protons found in the nucleus of one atom of that element. For example, the element hydrogen is made up of a hydrogen atom. Its nucleus will have only one proton, so the atomic number of hydrogen is 1. Now let's look at carbon, which is made up of carbon atoms. Its nucleus will contain 6 protons, meaning carbon's atomic number is 6. Interestingly, in any atom, the number of protons and electrons will always be the same. In our example, a hydrogen atom will have 1 electron, and a carbon atom will have 6 electrons. Because the positively charged protons are balanced by equal numbers of negatively charged electrons, atoms are electrically neutral. An atom's mass number is the sum of its protons and neutrons. In our example, carbon has 6 protons in its nucleus and 6 neutrons. So 6 protons plus 6 neutrons will give us the mass number of carbon, which is 12. An oxygen atom will contain 8 protons, so its atomic number is 8. Oxygen also contains 8 neutrons, making its mass number 16. Summary: atoms are the fundamental units of matter. Atoms are made up of protons, electrons, and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons have no charge. The number of protons in a nucleus of an atom is its atomic number. The sum of the number of protons and neutrons is an atom's mass number. The number of electrons will be equal to the number of protons in an atom.
All right, so based off of what you just learned, let's go ahead and look at these notes. So the definition of atom is basically anything that is matter, but it's the smallest part of matter. So the smallest unit of an element that maintains the properties of that element. So yes, electrons are smaller than an atom, but electrons themselves don't have any properties. In order for them to have properties, they have to be combined with neutrons and protons. So now this says complete the table using the word bank below and what you learned. So in this video, we learned that protons are positive. I remember that because protons and positive both start with a P. Neutrons are neutral. I remember those because they both start with an N, but that can get a little confusing because electrons are negative, and that also starts with an N. So electrons are my negative guys, neutrons are neutral, protons are positive. In the image, it said that protons are in the nucleus, so they're part of the nucleus, as well as neutrons are part of the nucleus. So the majority of an atom is found in its nucleus, and that is made of protons and neutrons. Electrons are those little guys that float around the nucleus. They float around in something called the electron cloud, and most specifically, they float around in electron shells. Protons and neutrons are where the majority of the mass is in the nucleus. So protons and neutrons are about the same mass. Protons are about equal to a neutron, and neutrons are about equal to a proton. Electrons, however, are almost negligible in their mass. They're matter, so they have mass, but it's super small. So it's significantly less than protons and neutrons. You would need almost 2,000 electrons to equal the mass of one neutron or one proton. So you can add and subtract electrons, and it really won't change the mass of an atom. Protons and neutrons are found by looking at, protons are found by looking at the atomic number. The atomic number is this number right here. So we'll go down to that one. Also, electrons and protons are equal. So if you know the protons are found by the atomic number, you can also see that the electrons are found by the atomic number. The neutrons, on the other hand, I can't look at the the periodic table of a square of an atom and figure out what the neutrons are. But I do know that this number down here, which is called the mass number or the atomic number, is the protons and the neutrons. And if I know these are the protons in the atomic number, I could figure out the neutrons by subtracting the atomic number from the mass number. And you will get your neutrons. So if you did the gizmo, you may have seen this. And also if you did the watch it, you'll have seen this. But there are particles that can change in an atom and it still be the same element. So for example, if I change the protons in an atom, I change to a complete different element. So can I change the protons in an atom and still be that same atom? Can I add a proton to gold down here and make it still be gold? You cannot. So protons define the identity of the atom. So I can't add or subtract protons and it still be the same element. Neutrons, however, you can change. If you change, add or subtract neutrons, you will get something called an isotope. An isotope is like a variation of an object. For example, you might be able to go in the store and you want to buy a certain pair of shoes. They have those shoes in 5 different colors. They're still the same line of shoe. They're still the same brand of shoe. They're still made of all the same stuff. It's just that their colors are slightly different. So they're variations within one type of thing. That's what isotopes are. They have the same number of protons, so they're still identified as the same thing, but their neutrons can change, which make them a little different, but ultimately they have the same makeup, so they're still the same elements. So your shoes, all made up of the same material, just variations in their color. Those things are called isotopes. Electrons, on the other hand, that's how atoms share different parts of themselves to make molecules and compounds. So if I have multiple different elements combining together, I will get something called a compound. So when you have water, you have 2 hydrogen atoms and 1 oxygen atom, and they're actually bonded together by their electrons. So when one atom shares an electron or another atom takes an electron from someone else, they'll be called something called an ion. Now, for the rest of this, we went over that this is the atomic number, which is equal to the protons and the electrons. This right here is the element symbol. The element symbol sometimes goes along with the element name, but depending on where the element was discovered, they might not make sense. So it doesn't make sense that Au is gold, but it does make sense that oxygen's is O. And then this number down here is the mass number or the atomic number. And that number again is the protons or the neutrons. Before we go over this down here, we are going to watch one more video.
There are more than 100 known chemical elements in the universe. Every element is different, but scientists have organized them into a chart called the periodic table. This table groups different elements together where they share similar properties. The first periodic table was made by the Russian chemist Dmitry Mendeleev in 1869. As more and more elements have been discovered, the table has been filled out. The table is structured so that the elements are arranged in order of increasing atomic number. Hydrogen, with the atomic number 1, is in the top left. It's then organized to show the similarities between elements. Elements are set out in vertical columns called groups. Those with the same number of electrons in the outer orbital, valence electrons, are put in the same group. Elements in the first column have 1 valence electron. Elements in the second column have 2, and so on. Elements in each column will share similar characteristics. Rows are called periods. They run from left to right. Each element in the same period contains the same number of electron shells. In period 2, all the elements will have 2 shells. In period 5, they will all have 5 shells, and so on. So, the group number tells us the number of electrons in the valence or outer shell. The period tells us the number of shells of electrons. Let's put it to the test. Fluorine is in group 7, meaning it has 7 electrons in its valence shell, and period 2, meaning it has 2 shells of electrons. What about magnesium? It's in group 2 and period 3. So it has 2 electrons in its valence shell and 3 electron shells.
All right, so back to our notes. If we look here, the atomic number is the number of protons and electrons in an atom. And the atomic mass number, we said right here, is where most of the mass comes from. Most of the mass comes from the protons and neutrons, so it's the sum of the protons and the neutrons. Now, the video just told us that groups or columns, when I think of columns, I try to think of social studies, and I think of like different types of columns, and those run up and down on the periodic table, or the fancy math word for up and down is vertically. This value indicates the number of this in an atom. Doesn't connect to the middle elements, which is why in that video, the middle part of the periodic table is kind of blurred out. This is the number of valence electrons. The valence electrons are the electrons in the outermost shell, and those are the ones that are going to be shared with other atoms so they can bond and make a new molecule. Periods and rows, just like when you put a period after you write a sentence, that sentence goes left and right on the periodic table, or the fancy math word for that is horizontally. This value, the period or row just in that table, that tells us the number of electron shells. That's kind of like the number of spaces the electrons have to fit in, to fit within the atom. So I like to think of this as when you guys go to the auditorium, we ask you to fill one row first and then the next row. Electrons fill the first row and then they move on to the second row and then the third row. So the shells would be like the number of rows that are needed to fit all the kids in the auditorium. In the period and rows, they change with an increase in the number of protons, or we said the protons are equal to the number of electrons in an atom. This should say electrons. So let's change that right now. So this should be electrons. Whoops, electrons. Okay, and then the last one is an isotope. Isotopes are atoms with the same number of protons and electrons, but different number of neutrons. That's what we talked about right here. So this would be the shoes you want, but the variations in the different colors. Okay, I hope this clears things up for you. And if you have any questions, let me know. And you're going to watch these 2 videos. Here's a login and password for that. And then this one right here, super fun. And then you're going to respond to this discussion post. Thanks. Have a good day.